Good morning, good afternoon, or good evening, whatever time you're watching this educational video. At this particular moment, we will be doing vector problems using analytical method. Before I will show you the problem, of course, do not forget to subscribe to this channel. Okay, I'm gonna teach you how to do vector problems using the analytical method. As we all know, we will separate the x components and the y components of this particular kind of problem. Let's begin. This is the problem. Forces x and y begin acting on a floating plastic object on water. The velocity of the plastic object is 0.12 meter per second in the direction due west. This scene is just within 120 seconds. Figure out the x and y components of the object's displacement during this time or this duration of time. Displacement sum, when we say displacement sum, that is just the total of the displacement x and y, or the hypotenuse of our right triangle. And then the direction provided, that the accelerations of our floating plastic object is 0.4, that's fx, and 0.22 for fy acceleration, as it's stated respectively. Okay, so we will analyze first what's going on in the problem. I will go back to the first one. We have two forces, x and y, and as we all know, when we will be solving for problems like this involving directions or angles, we need to really separate the x components and the y components. We have to be very careful with that. And then, yeah, there are forces x and y on a floating plastic object on water, as we assume that this the water friction or any other, let's say, resistance that is present in this particular problem is being neglected. Okay, and the velocity, the motion of the object, is 0.12 in direction of west. So we have to be very careful with west. We have to we have to put negative in our direction later on, and then the scene is happening in 120 seconds. Okay, so we have the initial velocity in the x provided in the problem. It's 0.12 meter per second, and it must be negative since it's due west. We'll use another color to represent the negative. We do not have initial velocity in the y-axis, so we can just plug in 0 meter per second. In the problem, in 120 seconds, that's the duration of the time, it has an initial velocity in the x that's due west, so negative 0, 0.12, and the initial velocity in the y is 0. We don't have velocity in the y. Provided in the problem is the acceleration in the x, it's 0.04 meter per second squared, and the acceleration in the y, it's 0.022 meter per second squared. And the time is 120 seconds. I guess we're all set in here. The first step that we will be doing is to get the, or to calculate the x component of displacement, or displacement in the x. So we can say by, or we can write it using our formula, displacement in the x, using the kinematics with our provided problem here. So we can definitely use this: initial velocity in the x times the time plus 0.5 acceleration in the x times t squared. The initial, it's in the given, 0.12 meter per second. Don't forget negative here. 0.5. Then acceleration in the x, it's 0.04 meter per second squared. Then multiplied by 120 seconds squared. I forgot to put 120 here. Vx, Vix, and then we have the time. So we will multiply it by 120 seconds here. Okay, so let's continue. Let's multiply negative 0.12 and 120. 120 times 0.12. The answer is negative 14.4. Plus, we will multiply first 0.5 and 0.5 times 0.04. 0.04. The product is 0.02. And the unit is meter per second squared. Going back to our previous term here, we can cancel seconds and seconds. So we have meters here. And do not forget 120 times 120. That's 14,400. And seconds times seconds, that's seconds squared. We can cancel seconds squared. Then let's continue. Copy 14.4 meters. We have to multiply 0.02 times 14,400. And the product is 288 meters. Okay? And remember, positive and negative, we will subtract these terms. So 288 minus 14.4, we will follow positive here because it has a greater absolute value. So the answer is 273.6 meters. This is the displacement in the x. Okay, we're done with the x displacement. We will have the displacement in the y. So we will calculate the displacement in the y, the components of displacement in the y. We will still use the same formula. Displacement in the y is vi in the y times the time plus 0.5 acceleration in the y t squared. As we all know, we do not have velocity in the y, so we will make it 0 here. And then plus 0.5 acceleration in the y, it's 0.022 meter per second squared times the time 120 squared. So we will multiply 0.5 times 0.022. It will give us a product of 0.011. Copy the unit. Then 120 times 120, it's 14,400. Then seconds times seconds, second squared. We can cancel second squared in our equation. So let's continue by multiplying 0.011 times 14,400. So the answer is 158.4 meters. This is the displacement in the y direction. Now we have the components of the displacement x and y. We can definitely calculate the displacement sum. Let's get the displacement sum. We have we got the components in the x, a displacement in the x, as well as the displacement components in the y. So all we have to do is to get the displacement sum or the total displacement by using the Pythagorean. So the x squared plus the y squared. If you could still recall, our dx is 273.6 meter squared plus the y 158.4 meter. Don't forget to square it out. Now let's have to do it manually. 273 times 6 raised to 2. It will give us an answer of 748.56.96 meters squared plus the squared of 158.4. Let's get the squared of it. So that's 25090.56. Then let's add 25090.56 plus 74856.96. The answer is 99947.52 then meter squared. Let's get the square root. Remember, magnitude is we will get the positive root. Okay, so square root of our answer, it will give us, by the way, we can cancel the radical sign and the squared. Our answer is 316.44777 meters, or approximately that's 136 meters. This is the vector sum, or the displacement sum. We're not yet done. We need to have the angle. Last is to get the theta. So we will be using theta is equal to inverse tan. And since we will use the x as our reference axis, so we will put the x here and then dy. Inverse tan, so dy is 158.4 meters and then 273.6 meters. We can cancel the units here. Let's have the quotient of 158.4 divided by 273.6. The answer, or the quotient, is 0.57894 and we will get the inverse tan of that using our calculator. So shift tan, then our angle is 30.06 degree, or approximately it's 30 degrees. So if we will try to draw, I will have this direction here as our x is positive and y is positive. So we are in the first quadrant of our Cartesian plane. And we will be using 30 degrees in the x as our guide. We will measure it here, assuming that we have our protractor. So let's say this is 30 degrees. And our vector sum is from there going to this direction. Okay, this is the vector sum that we calculated earlier. It's around 316.14 meters, if I'm not mistaken. That's the value of our displacement vector sum. So that's our final answer. The plastic object experiences an x displacement of 273 and 273.6 and y displacement of 154.158.4, resulting to a total vector of 316.14 meters directed 30 approximately 30 degrees. That's 30 degrees north of east. Okay, or we can say east, and we will measure 30 degrees north. That's the best answer. Thank you so much for watching. I hope you learned something from this video. If you like, of course, do not forget to give a like or subscribe to our channel. Bye for now.